So let's look at the measurement. Here I'll recall the state that was sent to us. Let's auto scale it so we see everything. And I used the speed test program to measure the cycle time. I'm looking at both sweep and transfer data time using manual triggering. And we'll send the complex data and we'll say, what does it take? And I enter the data in my spreadsheet. So like, for example, this was 5.82 milliseconds a cycle, or 5.78. I enter that number here. There's some variations within a few milliseconds between everyone. It's just a roughly average. So 5.878 for this sweep. We can make it faster by widening the bandwidth. So I'll go to 1 megahertz and I'll run it again. You can see here it updates that it's at 1 megahertz now. 4.68. I can, this is a 2-port cal. I can make it faster by going enhanced response cal, which is a single direction calibration versus both directions. So I pick a subset. You can also just do an enhanced response from the very beginning. But you'll notice I won't quite get the speed improvement here, 4.59, because I'm still measuring the reverse parameters S12 and S22. So it's still taking that reverse sweep. So if I delete the reverse S parameters, I have an enhanced response cal and only my forward S parameters. Now it saves me time. So now it's 2.88, this number here. And you can make it even a little bit faster if you use a trigger method called single, which uses COM. It's not much of a savings in time. It's just very little. Well, here there wasn't even anything. Sometimes it ends up a little bit faster, 2.84, 2.80. But COM in general is our absolute fastest, but it's really not much. The other point is if you want to use a shared memory to store the data on that computer before transferring it, what you save is the data transfer time. And let's just test the data transfer time for this setup. It's really only 0.15 millisecond, which is what I entered here. I'll run it again. So 0.15 milliseconds. That's it.